3.2, part 1, sine, cosine, tangent. Here we go.
In this course, we're going to approach angles in a way that may be different than what you have seen in the past. We will approach angles in a generalized method that allows us to view them through the periodic lens. To do this, we must first make a few clear definitions. Definition 1, standard position. In the coordinate plane, an angle is in the standard position when its vertex is at the origin. In one ray, the angle lies on the positive x-axis.
All right, so this is going to be our standard position, so we're always going to start with this x-axis and then move from there. All right, keep going.
Definition 2, terminal ray. The terminal ray is the second ray of an angle in standard position.
All right, so our terminal ray is where we're going to end up. All right, and so we're always going to end up counterclockwise going on, unless it's a negative, obviously, but a normal angle measure is going to go counterclockwise that way from our standard position to go to some ray. All right, keep going. You're doing great.
Sine, cosine, and tangent. Given an angle in a standard position in a circle centered at the origin, there is a point P where the terminal ray intersects the circle.
All right, so we're going to stop there. All right, so there was this Native American princess, and does anybody know her name? No, her name was Toa. All right. And so there was our Native American princess, Soka-Toa. And so sine is what? Opposite over hypotenuse. And cosine is what? Adjacent over hypotenuse. And tangent is opposite over adjacent. Now, when we're dealing with any triangle or any circle for that matter that represents infinite amount of triangles, our radius is going to be our hypotenuse. Okay, and so this is going to be represented as our hypotenuse, and it's our radius. It's how far out we go to our circle, right? And so this measure right here is our x, all right? And then this measure right here is our y. Now, our x deals with what part? Is it the adjacent or is it the opposite side? It's the adjacent, because adjacent means next to. And so x's deal with the adjacent side. And our y's deal with the what? The opposite side, okay? And so if we're dealing with a sine of theta, sine means what? Opposite over hypotenuse. And our opposite is going to be our y value over our hypotenuse of our radius, okay? And then our cosine is what? Adjacent over hypotenuse. Now, in this term, our adjacent is going to be our what? Our x value, and our hypotenuse is our radius. Make sense? And then our tangent is what? Our y over our x, but it's really what? Our opposite over adjacent. And our opposite is our y over our adjacent of x. All right. Now, before we get into the other parts, if I move horizontally, if I move right, my x is positive, right? If I move left, what do I know about my x's? They're negative. If I move up, what do I know? My y is positive. When I move down, my y is negative. My r is always going to be positive. All right. Why is my r always going to be positive? Because it's a positive distance. It's my hypotenuse. All right. So r is always positive. X and y's can be negative. All right. We're moving. One. Here we go.
The figure shows a circle centered at the origin with an angle of measure O in standard position.
Theta.
Angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point P. The coordinates of P are x and y. Which of the following is true about the cosine of theta?
Theta. Good. So we're talking about cosine. And cosine deals with what? The adjacent over the hypotenuse. So if this is my angle measure, this side right here is what? The x. And then my hypotenuse is what? My radius. Now, what is my radius here? It goes out how far? 3. And so my radius is 3. And so the cosine of theta is equal to what? X over 3. And which one says that? A. David, example 2.
The figure shows a circle with radius 5 centered at the origin with an angle measure of theta in standard position. The terminal ray of the angle intersects the circle at point P. Find the following values.
All right, fantastic. So what's my radius on this one? 5. My radius is 5, so let's just mark it as 5. And so what is my x value here? It gives my point here 3, 4. So what's my x on this part? 3. Now, what's my y value for this part? It's not 4, but why? It's negative 4. Why is it negative 4, Miranda? Because it goes down. It's below the x-axis. All right? And so now that we have this, it's all pretty easy. So how do I do sine? Sine is what? Opposite over hypotenuse. So what's my opposite? Negative 4 over my hypotenuse of 5. Cosine of theta. So cosine deals with what? The adjacent over hypotenuse. So what's my adjacent? 3. My hypotenuse is 5. The next one is tangent of theta. And tangent is what? Opposite over adjacent. So my opposite is negative 4 over my adjacent of 3. Okay, so on this one, okay, so we have a lot of things crossing, and so I have point P being x and y. And I just want to find all of the points here. So let's do point Q first, all right? First of all, what's my radius? My radius is just what? R, all right? So all of these have a radius of R, all right? So all of those have a radius of R. Now, point Q. So if point P is x, y, point Q would be what? Negative x, comma, negative y. It's going too soon. And so then point R, oh, it's not negative y, thank you, positive y. And so point R would be what? Negative x, comma, negative y. And then point S would be what? X, comma, negative y. All right, beautiful. All right, so example 4, it says, hey, find the sine for point S. All right, and so we're finding the sine of point S. Well, what's sine again? Opposite over hypotenuse. So what's my opposite when I talk about point S? Negative y. So now I have sine of theta, which would be equal to negative y, which would be my opposite, over my hypotenuse, which is what? R. All right, let's look at example 5 now. And so example 5 says find the cosine at point Q. And so point Q is up here. And so what is cosine? The adjacent over the hypotenuse. So what's my adjacent? Negative x over my hypotenuse of r. All right, let's go to example 6 now. So on example 6, it says find the tangent at r. And so tangent is what? Opposite over the adjacent. So what's the opposite? Negative y. What's my adjacent? Negative x. So now I have negative y over negative x. And so what happens when we have a negative negative? It's positive. So now we have y over x. All right.
Let theta be an angle in standard position whose terminal ray coincides with the line y equals negative 3x in quadrant 2. Find the following values.
All right, so on this one, I'm going to help draw this. So we have our coordinate axes, and it says our line y equals negative 3x. So I personally am going to draw a picture on this one. And so what does the line y equals negative 3x look like? Which way does it go? Which way? What's the slope? Its slope is what? Negative 3. And so it's going down that way. Yes? And so the triangle that I'm trying to make is this one right here. Everybody follow what I'm saying here? All right. Now, does it say exactly what the x value is and the y value? Does it say either one of those? No. So I'm going to make one up. All right. So I personally am just going to make up a number. And I'm going to use a simple number, and I'm just going to say this is 1. However, I can't use 1. Why not? Because which way did the x go? It went back. So I'm going to use what? Negative 1. All right. So I'm just going to say this is negative 1. You can use any number because it won't matter because it will simplify the ratio anyway. All right, so I'm just going to use negative 1 there. Now, to find the y value, my x is negative 1. What would be my y value? Positive what? 3. And so my y value is positive 3. Do we see how we did that? If I picked negative 2, then my y value would be 6, but it would have the same ratio. Does everybody follow? All right, so I just made a couple up. All right, and so now I want to solve for my hypotenuse. All right, and how do you solve for a hypotenuse given a right triangle? A squared plus b squared is equal to c squared. All right, that crazy Greek dude Pythagoras. All right, and so now what is my legs? So now I have what? Negative 1 squared plus 3 squared is equal to c squared. So negative 1 squared is what? 1, 3 squared is 9. So I have 1 plus 9, which is 10. And then I want to square root it. So c is equal to square root 10. All right. And so that's the triangle that I'm going to draw. All right. So now let's kind of use that now. So now I have sine of theta equals what? So what is sine again? Opposite over hypotenuse. So what's my opposite? 3 over the hypotenuse of square root 10. So we're going to multiply by what? Square root 10 over square root 10. And so then we end up with 3 square root 10 over 10. All right, so if we needed to rationalize, there we go. All right, and then this next one is cosine of theta. And cosine deals with what? The adjacent over the hypotenuse. So my adjacent is what? Negative 1 over square root 10. And so then if I needed to rationalize it, I'd multiply by square root 10 over square root 10 again. And so now I'd have what? Negative square root 10 over 10. All right, and now tangent. And so tangent of theta. And so tangent is what? My opposite over the adjacent. And so my opposite is what? 3 over my adjacent of negative 1, which simplifies to negative 3. All right. Now, one of the things that I want you to see here is the tangent of theta is going to be the slope of this line. All right. Because what is slope? It's the change in y over change in x, right? And so if it's the change in y over the change in x, it's the same thing as the slope. All right, so there's a nugget for you.